Hey guys, this is Super Testnet, and today I wanted to show you my implementation of Rule 110 in Bitcoin script. So this one's going to get a little bit technical. I've got an IDE showing here with some computations that it's doing, and I've got a Bitcoin transaction where I did this stuff on the actual Bitcoin network. Well, actually on the testnet, but and then I've got to explain what Rule 110 is and why it's cool. So let's dig in. Rule 110 is a very popular cellular automata. Cellular automatons or automata are mathematical constructs that involve these black and white squares and these patterns that they produce. So how you create a cellular automata, and I'll get to why they're interesting in a minute, is that you create a grid like this one of mostly white squares, and then you put black squares in some of them. Typically, you start out just using the first row, and you put like 1 in the middle of the first row or something like that. And then you have a set of rules, which are listed up here, for how the second row and the third row and so forth should automatically be generated from the first row. And so in this example, if there is a white square surrounded by a white square next to a black square next to a white square, that corresponds to this rule right here, white, black, white, and so it drops a black square down onto the second row. And then this one's computed because it's white, white, black, which if you look up at the table up here, white, white, black means you drop a black one down right there. And so on and so forth. You just provide the first row as input, and then all of the other rows get propagated automatically. That's what a cellular automata is, and mathematicians study them because they are useful in learning how computation works, as well as how life can develop and grow and stuff. There's a lot of things you can learn from these things. But this one, Rule 110, is particularly interesting to computer scientists because the pattern that it generates allows you to make computations. In fact, you can simulate any computer program by just providing the right set of inputs on the first line. You can actually make it you can make it compute stuff. You can make it calculate numbers, or you can make it run a basketball video game or stuff like that. And what you basically do is you supply the right inputs at the top. You learn how the pattern manipulates that information, how it changes as it propagates down, and then you can decide, or you can learn to program this thing so that like your desired output will always be displayed on, line 5,264,000 or something like that down the image. Anyway, I bring it up because Rule 110 is something that I implemented in Bitcoin script recently, and then I executed a transaction right here on the blockchain with this long witness script that actually runs this program. It actually creates Rule 110 and does the first 3 generations of it, which is these first 3 lines here. It actually computes what those should look like. So I wanted to show that to you, but before I move on with this, what this means, I think, if I didn't do anything wrong, I think this means that Bitcoin's programming language, Bitcoin script, is Turing complete, meaning it can compute you can run any computer program in it, or at least you could if you had enough storage space. Bitcoin, of course, has limits on the size of transactions, so you still can't do anything, but all computers have limits. So this one is just pretty severely limited. So I made this program in an IDE called Scriptwiz, which is designed for writing programs in Bitcoin script. And I want to show you how this works. So you put inputs to your program up here. These are like what a user might supply as inputs to a transaction, or with their transaction inputs. Like they would supply a signature, and they might supply pre-images if it had to do with Lightning. And in my program, they also supply zeros and ones as inputs to the program. And those are displayed as stack elements. Bitcoin's programming language is stack-based, and everything the user supplies is just concatenated onto whatever was on there previously. And so when they supply 9 zeros and a 1, as in this example, it shows up in script as a row of 9 zeros and a 1. And then the program starts down here. So this begins manipulating the data that the user supplies. In this case, it manipulates all of this. It starts computing what it takes the first three digits, which are these ones, 001, and it computes what the Rule 110 corresponding successor cell should be. And you actually can watch it go down here. It takes it a long time to compute it as it's going through a whole row of these things. But what it ends up with is this should be the second line of a Turing machine. Sorry, this line right here should be the second line of a Rule 110 pattern if you give it just a bunch of zeros and ones as an input. So you'll notice what it basically does is it adds another one onto it right there. And that's what happens in Rule 110. You start out with just one cell black here, and you end up on the second row with everything still white except for these two. So that's actually the same thing. And then the program then takes this as input and does it all over again and gets down to this stage right here, where now there's three. There's a bunch of whites that correspond to zeros, and then three darks, 1, 2, and 3. And that matches with this pattern. It's a bunch of whites followed by three darks. In mine, I ignore everything to the right side because the Rule 110 automata doesn't have anything on the right side. It all just goes down to the left, down and to the left. But if you keep doing that, you go all the way down all these lines. You get down to this one where it's 1101. That matches black, black, white, black, and so on and so forth. It actually computes all of the rows. There's 5 blacks in a row, which is this line, 5 blacks in a row, and so forth. And then, so yeah, you can actually, what this allows you to do is not just compute this particular image, but if you supply different inputs at the top, like let's say you had a dark here and a dark over here, and I don't know, maybe half were darks and half whites, you'd get different images that would propagate downward. And it's by messing with the inputs you provide over here that you can actually program stuff and write computer programs that give outputs on certain lines. And this script proves that you can do that in Bitcoin and compute any program, as long as it's limited to the amount of size that actually works in Bitcoin. So speaking of that, this program, as I write it here, doesn't run on the Bitcoin network because it is too long. It exceeds the limits of Bitcoin script and of the limitations that Bitcoin places on how many operations you can have, the size of a transaction. But I did get it to run a very small version that only does the first 2 generations of the program. So it only computes on here. It only computes this line and this line after being given this line as input. But it runs. Like, this actually shows that you can simulate the rules of Rule 110 in Bitcoin script. Oh, not that one. This one, which is much smaller. It's only 248 lines and of code. And this one actually runs in Bitcoin, and Bitcoin nodes will compute this for you and then give you the results, which is really neat. So I have a transaction here where I actually did run it, and when I spent the money that went into this Bitcoin address, the nodes had to validate that the script executed truthfully, and therefore all Bitcoin nodes, or at least the Bitcoin testnet nodes, had to run a Rule 110 virtual machine, which is cool. So I put a virtual machine on Bitcoin, and now there's this little computer program running on Bitcoin that you can program. It's not very powerful. I mean, you can only put in 4 bits of data, and you'll get out some pattern like this. You'll get out this pattern if you put in 0001. But yeah, it's actually a programmable little computer running on Bitcoin's blockchain, or the testnet blockchain anyway. So yeah, I thought that was neat. Thought people might like to see that. And there's more details about how this works in my GitHub. And I think I proved, unless I missed something, which is always possible, I think I proved that Bitcoin script is Turing complete. Just like other blockchains have Turing complete programming languages, Bitcoin has one. So I think that's kind of cool, and I hope you guys agree. Thanks for watching. Talk to you later. Bye-bye.